Welcome to our YouTube channel Incredible Maths. In this video we will see the concept of order of an element of a group. So this is the ninth lecture of the abstract algebra lecture series. So the definition: order of an element in a group. Let G be a group. So this may be finite or infinite group. So in the last video, we have seen the definition or concept related to order of a group. So what is my order of a group? That is, number of elements in the group is given by order of the group. If the order of n is finite, then we classify the group as finite group. If order of G is infinite, then we classify G as an infinite group. So let G be a group and an element A belongs to G. If there exists a least positive integer n such that a power n equal to e, where here e is the identity element of G, then we say that order of A is n. If there exists a least positive integer n such that a power n equal to e, then we say that order of A is n. So A is the element. So here G is a group and A is an element in G. So if there exists least positive integer n such that a power n equal to e, then we say that order of A is n. And denoted by order of A equal to n. So the integer should be a least positive integer. So we will see an example. So let us consider the group G equal to 1 minus 1. So under the operation multiplication, so this is a group. So this we can easily check using the concept of Cayley's table. So Cayley's table, so the operation is dot. So the element is 1 minus 1, 1 minus 1. So we will multiply 1 into 1 because operation multiplication. 1 into 1 is 1 and 1 into minus 1 is minus 1. So minus 1 into 1 is minus 1 and minus 1 into minus 1 is 1. So here we will mark the identity element. So identity element is 1 for this group. So to find inverse, so we draw the horizontal line. So from each element, from each row, such that the line meets the identity element, then draw the vertical line. So this means that inverse of 1 is 1. So this is shortcut to find the inverse of an element. So similarly, draw the horizontal line starting from minus 1, this row, such that the line meets the identity element, and draw the vertical line. So the inverse of 1 is 1 and inverse of minus 1 is minus 1. So this will be a group. So moreover, it's an abelian group, so that we will see later the definition of abelian group. So now we will find the order of the elements 1 and minus 1. So that is order of 1. So as per the definition, it's the least positive integer n such that a power n equal to e. So 1 power 1, so this is equal to 1. So this is the identity element. So therefore order of a is, so this will be order of 1 is 1. So because it's the least positive integer, so even though it satisfies 1 power 2 equal to 1, so 1 power 3 equal to 1, but this one is the least positive among these integers 1, 2, 3. Therefore we call this one as the order of this element. So now we will find order of minus 1. So the minus 1 is the element. So we will raise this power of minus 1 so as to get the identity element. So the identity element is 1. So minus 1 power 2 is 1, and minus 1 power 4 is also 1. So minus 1 power 6 is also 1. So among these 2, 4, 6, okay, so we have to find the least one. So the least one is 2. So therefore here the least positive integer is 2. Therefore order of minus 1 is 2. Order of minus 1 is 2. So we will see one more example. So we'll take the example. So we have seen in the previous video. So that is, if we consider G as 1 minus 1 I minus I. So under the operation addition, so G is our set is 1 minus 1 I minus I. So we will find order of each of the elements. So order of 1 is 1. So because 1 power 1 is 1. And next we will find order of minus 1. So find order of minus 1. So minus 1 power 2 is 1. So this is equal to identity element. Therefore this implies order of minus 1 is 2. So next we will find order of I. So I power 1 is equal to I. So this is not equal to identity. So here for this group identity element is 1. Okay. So I square is minus 1. So again this is not equal to E. And I cube is minus I. Again this is not equal to E. I power 4 is 1. So this is equal to identity element. So therefore this one so will be the order of I. Order of I is 4. So this 4 comes here. So here also we can check that so I power 8 is also 1 and I power 12 is also 1. So but the least positive integer among these is 4. Therefore order of I is 4. And similarly so we can check order of minus I. So we can take this as a exercise and find the order of minus I. And you can find the order and comment your answer in the comment box. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. So in the next video we will see what is meant by cyclic group. Thank you.